Structured questions of electricity, mixed questions. Question number 56. State the relationship between the resistance R and length L of the wire at constant cross-sectional area directly proportional. You can just say R proportional to L, or you can say directly proportional. Resistance R and cross-section area A of the wire for constant length. You can either say like this, or you can say inversely proportional. P, a 60-watt filament, 60 watt, power is equals to 60 watt. 230 volt, V is equals to 230 volt. Calculate the current, I is question mark. The formula you know, P is equals to VI. I is equals to P over V. Substitute power 60, 230, 0.261. I don't know.
2.61.
2 point? You are wrong. 0.26 amperes. Make sense? Should? It's correct. Okay, I want you to put double star on this question to get back to this question in future and solve it multiple times. Multiple times. The lamp Y has a filament, same metal as lamp X. The lamp has half the length of the and 1/3 the cross-section area. I want to stop here as X. As we have two lamps, my dear. How many lamps? Here is lamp X. Here is lamp Y. Lamp X has the filament has half the length and 1/3 the cross-section area of X. Okay, lamp X. Lamp X was previously, yeah? Resistance is V over I. Lamp X was 230 over 0.261. Please give me a bit precise answer, I mean long answer, at least 4 to 5 significant figures.
881.22605.
881.226 ohms. This is the lamp X, my dear. I wanna go for the lamp Y now. Read the question again. The filament has half length. Stop here. Make table. Length, resistance. 1/3 cross-section area. Area, resistance. If length is half, yani length is divided by 2, resistance will also be divided by 2. 1/3 area. Area is divided by 3. 1/3 means divide by 3. So it means resistance will be multiplied by 3. So resistance of Y will be what? What was the resistance of X? 881.226. Now, as per the law up, we said resistance will be divided by 2 and resistance will be multiplied by 3. The resistance of Y comes to be 1321.84 ohms. Okay, we are done 2 steps. Step 1, we found the resistance of X. Step 2, we found the resistance of Y. Step 3, current in Y. Current in Y. Current formula, you know, I is equals to V over R. Voltage is still same. They say lamp Y is also connected to how much? 230 volt. So 230. What is the resistance of Y now? 1321.84. So current in Y comes to be how much? 174. And the last step is, each step is awarding you 1 mark. The last step is ratio of current in Y divided by current in X. Current in Y we found 0.174 and X was 0.261. What's the answer? 2 over 3? Yes. So ratio 2 over 3, 2 ratio 3 or 0.67. Whatever you want to write, you can write the answer. Choice is yours. Before I did the question, I told you put double star on this question. Okay, so you can review this, you can rewatch whenever you want. This is the proper way. So first we found the resistance of X. Using the length and area factor, we found the resistance of Y. And then we found the current. And after finding the two currents, we divided them and we got their ratio. Next question. I give you like 27 seconds to absorb this information. Last 7 seconds left. Three more seconds. Must. Next question. This question I would like to solve with you. Question number 57. A piece of wire has a resistance 0.25. Calculate the resistance of another piece, same material, with a third of length. Table method. You remember table method? Length with resistance, area with resistance. Now, what do you mean by a third of length? So length is divided by, so resistance will be multiplied by, resistance will also be divided by, because the resistance is directly proportional to length. Area, half area. Half area, I mean, if area is divided by 2, resistance will be multiplied by 2. So because resistance is inversely proportional to area. So what will be the new resistance? 0.5. You divide by 3, then you multiply by 2. 0. That was 0.45. 0.30 ohms. Make sense? Make sense? Figure shows our resistance with 3 resistors, a power supply, and 4 voltmeters. Okay, voltmeter V1 is parallel to battery. It's a good concept of parallel and series. V4 is also parallel. Please look, how many of you think that they are same readings? V1 and V4. They are same. They both are connected parallel to battery. You can look. Can you see V4? is also parallel to battery. So before I read the question, I would like to tell you that in this question, V1 is same as V4. Now, this circuit I'm shading with a green color is series. This is, so this two, can I say this V2 plus V3, V2 plus V3 is equals to V4. Or you can say V2 plus V3 is equals to V1. Because they are in series, the voltage is distributed. Voltage is distributed. Today in MCQs, I told you a law. Law, I told you the sum of currents entering into a junction. Is this current entering into this junction? Or no? Is this I3 also entering into the junction? Very good. How about I4? I4 is leaving. So sum of currents entering I2 plus I3 is equals to currents leaving. Now wait, stay with me. How about this junction? Here current entering is I4. But current leaving here is what? I1. So can we say I4 is equals to I1? Okay, we made many relationships before we solved the question. Sum of currents entering into a point is equals to sum of currents leaving that point. Now let's read that question. Calculate the combined resistance of three resistors. 1, 3, 2. 1 ohm, 3 ohms, 2 ohms. First you do parallel. For parallel, I told you, you do product over sum. Once you found the parallel, then you go total. This parallel was 0.75 and the other one is 2 in series, 2.75 ohms. .75 ohms. Makes sense. Write down two relationships for the currents in the circuit. We already wrote. I told you current entering is equals to current leaving. So one was I2 plus I3 is equals to I4. And then we said I4 is equals to I1. Two relationships they asked. We already decided. Make sense? Sure. Next. Write down the two relationship between voltages. I told you the battery voltage was same as V4. Yes? And then you also said the voltage which is in series is added up. V3 plus V4, sorry, V2 plus V3 is equals to V4. Two relationships of currents, two relationships of voltages. We already decided the two relationships. Next question. Question number 58. Series circuit II. Since they are in series, so current is same. Current is I, current is I, current is I. The current is same in series. So go to the current column. Go to the current column. So since they are in series, so current has to be same. Potential difference. Potential difference, my dear, you know V is equals to I into R. You just need to multiply these two. R times I, IR. Power. Power is equals to I square R. Now here, the last column, I is I, but R is what? 2R. So answer will be 2I square R.
Nice.
Next question. 8.2 represent the system used to transmit electricity from power station to our factory. Power station voltage is 11,000 volts and current is 750 amperes. You have a factory power lines. The power station generates 11,000 volts, price occurrence of 750 amperes. Total resistance of power lines between the power stations and the factory is 1.5. Power output of power station. Easy. You have the voltage of power station. You have current of the power station. So P is equals to VI 11000750. Sure.
825 40. 8.25.
8.25. You can round to 8.3 also. 10 power 6. Okay, we get the power. Make sense? The potential difference across the 1.5 ohm power lines. V is equals to IR. The current is 750. The resistance is 1.5.
11.
Sorry?
1124.
1100 volt. Make sure you write the actual value. Don't skip it. I just rounded to two significant figures. But in the next question, we need to use actual. The last part is the trick part. The power supplied to the factory. That's the problem. What was the input voltage? It was 11,000 volts. Yeah? How much PD loss in wires, in lines, this is called line loss. That is 1125. How much? This voltage which you calculated up, this was lost in the lines. Look, here was the total voltage 11,000. For these lines, the voltage 1125 volt loss. So here is the remaining voltage in the factory. So voltage for the factory will be how much? Factory voltage will be 11000 minus 1125. Calculate. $9,875. So resistance you already, sorry, the current you already know, which is 750 amperes. So P is equals to VI. Voltage is 9875, 750. $7.4 into 10 power 6. So total power was 8.3. The delivered is 7.4. Next question. A very interesting, easy, and conceptual question. A student sets up a circuit containing 3 identical cells. Each cell has an EMF of 2 volts. Very interesting. How many cells? 3. Each cell, 2 volt. What does that mean? 2 volt, 2 volt, 2 volt. Yes? So what is the total EMF of the battery? 6 volts. 6 volts. Ammeter reads 0.25, means current. State the name of unit in which charge is measured. The unit of charge is coulomb. Calculate the charge that flows in 12 minutes. 12 minutes mean 12 multiplied by 60. The time is 720 seconds. Charge Q is equals to IT. I is 0.25. T 720. 180 coulombs. Is that 180 coulombs? All right. The metal wire has resistance 16 ohms. Go right there. How much? 16 ohms. The metal wire. On the diagram, I indicated 16 ohms. Find resistance X. To find X, we need total resistance first. So first, can I find total resistance? Is the total voltage over total current. Total voltage, you know, my dear, 6 volt. Total current, 0.25. So total resistance is 24 ohms. This is the total resistance of whole circuit. Now in the circuit, what do you have? Go back. You have 16 for the wire plus X. So it means the X plus 16 is 24. X is 24 minus 16, 8. So using the total current and total voltage, we found total resistance, which came to be 24 ohms. Since the wire is in series with the X, total is 24. So series resistance X and wire are to be added. X plus 16 is equals to 24. You rearrange, you get the value of X. 16. 24 minus 16 equals to 8. The same wire is cut into 2 equal halves. Two equal halves. So if length is divided by 2, resistance will also be, so 16 divided by 2, 8. So first wire is 8 ohms. Next wire is also 8 ohms. And now they are what? Parallel. So let's go for parallel. The 2 wires are now parallel. So 8 times 8 over 8 plus 8, which is equals to 4 ohms. Which is equals to 4 ohms. You need to write this also, wherever you want to write. That since the length is half, so resistance of each will also be half. Each. So each length is half, so each resistance is half. So we still have like 25 minutes. Next question. Our digital watch is powered by 1.3 volt cell. The cell supply, okay, so voltage you have the current ampere you have, time T you have, 1.6 into 10 power 7. Find the charge. Charge symbol is Q. Q is equals to IT. I is 4.1 into 10 power negative 5. T 1.6 into 10 power 7. Five. 656 coulombs. You can write 656 coulombs exactly if you want. The resistance of electrical circuit. So resistance is V over I. Voltage is 1.3. I is 4.1 into 10 power negative 5.
3177.
31.
707.
How O is a number?
That's how they say it.
Excuse me. It's 07. 3.2 into 10 power 4. O is not a number, please. Output power of a cell, P is equals to VI. They are testing all equations here. 1.3 times 4.1 times 10 power minus 5.
Five point 33 times 10 to the power of negative 20.
I squared R, yes. V squared over R, yes. Any valid equation could be used. Open the next question. Figure 9.1 shows the current potential difference graphs for a resistor and a thermistor. Calculate the resistance of thermistor when the potential difference across it 7 volts. 7 volts. Let's look 7 volts. Here is the 7 volts, right? Go to the graph at 7 volts and tell me current. It is 4.6, right? Amperes. So resistance of the thermistor, so R is equals to V over I. Voltage is 7. Current is 4.6. 1.52. We do not say combined digits after decimal. That's a wrong mathematical interpretation. That's wrong. That's absolutely wrong, my dear. Okay, next question. The table 9.1, tick the boxes to indicate the effect of resistance of the resistors and the thermistor when PD is increasing. Go. Can you see resistor is a straight line graph? Resistance is a constant. Resistance of thermistor is constant. Sorry, resistor. And now thermistor. Now, actually, even if you don't look at the graph, I know the answer. When there is more voltage, there is more current. More current means more heating effect. More temperature means less resistance for thermistor. Thermistor, temperature and resistance have opposite relation. You know that? Thermistor. There are two things. One is metallic conductors, filament, heater, lamp. More temperature, more resistance. Thermistor is a semiconductor. It's a heat sensitive device. So for thermistor, If temperature is more, the resistance will be less. This is the graph you asked me today. As it is increasing, yeah. Next question. The thermistor and resistor are connected in parallel. Find the current. In parallel, the current is added up. Individual currents, you add up current of resistor plus current of thermistor. It will give you total current of supply. Yeah? Now go to the graph at, we don't need to apply any equation or rule. Just go to the graph and tell me when the voltage is 7 volt, how much is current for each? They both have 4.6. 4.6. If you don't understand, I can help you this way. Here is the resistor, 4.6 amperes. Here is the thermistor, also 4.6 amperes. They are connected parallel to the supply. So how much is the supply current? 4.6 plus 4.6, 9.2 amperes. Make sense? They are in parallel. And when we went to the graph, each of them, they had 4.6 at 7 volt. The current in both is 4.6. So they are in parallel. Now look at this diagram. 4.6 for thermistor, 4.6 for resistor. So they are in parallel. If you add them, they will give you the total current by the supply. Energy transfer in 5 minutes. 5 minutes, time is 5 multiplied by 60, which is 300 seconds. 300 seconds. So energy E is equals to VIT. Voltage is 7 volt. Current is 9.2. Time is 300. 1.9 into 10 power 4 joules.
Can I write that one?
Yes, my dear, you can write. 1.9, I wrote just two significant figures. You want to write 3, you can write. I don't mind. You can write the exact answer like 19,300 as well. Next question. 62. The figure 8.1 shows a circuit. The lamp has a resistance of 3 ohms. Right, it's written. Line XY is a uniform resistance wire, 6 ohms. Calculate the reading on the ammeter. Ammeter reading means current. So you want to find I. Ammeter reading is actually giving you the total current, yes, which is by the battery. It's a master. So total current, you first need the total resistance, which is 6 plus 2 plus 3. Total resistance is 11 ohms, right? So I is equals to V over R. The voltage is 12 volt over 11. 1.1 amperes. 1.09, so 1.1. So ammeter, they ask you indirectly ammeter reading. They didn't say it's the current. You should know the ammeter gives you the current. Next. The figure 8.2 shows the circuit with the different connections so that there is a star question. Put double star. You will rewatch this question 2 times, attempt again. The figure shows the circuit with the different connections to the resistance wire and added resistors. The length XY of the whole resistance is 2 centimeters. But now in the section XQ, it is 2 meters is the whole. Right now, 0.6 meters is now. The contact is made at Q, where the distance is 0.6. Find the resistance of circuit. So my dear students, the first section is resistance is directly proportional to length. So previously, the length of XY was total how much? 2 meters. Sorry, 2 meter was 6 ohms. So here, length, resistance. Length was 2 meters. Resistance was 6 ohms. Now, the length is 0.6 meters. Resistance, how much? So give me the resistance of XQ. 1.8 ohms. Step 1. Step 1 was to find the resistance of the wire. Step 2 is parallel. What? Parallel. Now, this 1.8 is actually here. So 1.8 is parallel to 1.5. So 1.8, 1.5, 1.8, 1.5, which is no, first parallel, then series. You first need to do parallel. Once you do parallel, then you will do series. Step 2 was parallel resistance. Step 3 now total resistance. So total will be now parallel 0.82 plus 2 plus 3, 5.82. So here, first we use the proportionality, the step 1. Then we found parallel. Then we found total. You get 4 marks. Last question. Last. Question number 63. Define EMF. It can have 3 key sentences. I will use 2 of them. First is amount of, you can say work done, you can say energy supplied. Per unit charge. Yes, in moving the charge from charge through or across the whole circuit, complete circuit. So EMF we say moving the charge through whole circuit. PD we say moving the charge through a component. Good. Voltage of the battery is 60 volt, which is EMF.
What about the question of unbiased?
You can write, it's 1 mark, but if there is enough, you can write them. It's converted from other forms into electrical. Yeah, per unit charge. In moving the charge, per unit charge must be. A heater has a resistance of 22.5 ohms. PD across it, here the voltage is 45 volt. A complicated one. So if heater, you want the power of heater. For heater, you have resistance 22.5. Voltage, please don't use 60, use 45. So P is equals to no other equation, V square over R. So 45 square over R, 22.5. 90? When? 90 watt. PD across X, this is easy. Total voltage is how much? Minus heater is 45. My dear, in series the voltage is distributed. So if total was 60, so this is 60 minus 45. Both get 15 volt, 15 volt. Total EMF is 60. So if H got 45, So remaining is 15, which is for the parallel. Parallel, the voltage is same, so both will be 15 and 15. In parallel, the voltage is the same, not added up. We do not add the voltage in parallel. No, we don't add. It is 15 plus 45 is 60. He's adding. I know how he got 75. In parallel, we don't add the voltages. Voltage is product over sum.
I would like this. That's for it.
Current in 10 ohms. Easy. For 10 ohm resistance, voltage I already told you how much? 15. So current will be V over R. 10 or 15 over 10, 1.5 amperes. Thank you.